All right, so yes, I'm Mathias Ekstedt. I am one of the founders of ForCity, but I spend most of my time in academia at the Royal Institute of Technology, which is KTH in Swedish, in Stockholm. I was asked to talk a little bit about the study we did a couple of years back now, and related to the CVSS, which is something that we end up touching quite often in many different contexts. And essentially the background to the study was that, well, there has been a discussion on can the CVSS be trusted or not. So that was our goal to say, answer that question in this study. So I will warm you up now with some academic work, some theory. Well, I hope I won't make it too academic. All right. So the CVSS, I think that most of you know about it. You encountered it, but very quick overview. The CVSS is essentially a way of communicating and trying to characterizing severity of software vulnerability. So top line or bottom line, depending on how you see it, vulnerabilities can be scored with a number ranging from 0 to 10, essentially saying something about the severity. It is used by, in particular, various vulnerability databases, and I think NVD perhaps being the most renowned one of those. In those databases, we normally encounter CVEs, common vulnerabilities and exposures, like identities of vulnerabilities, and they get a score. So for instance, here is just a random pick from NVD that this CVE now has a score of 7.8, which is regarded as a high or a high severity. All right, the way to come to that score, and perhaps the score per se is not so much of interest for the study here, is there's a number of underlying metrics that are used to come up with that. And this is also the characterization of the vulnerability. So most commonly known or used are the base metrics. So every vulnerability is characterized by its attack vector, its attack complexity, if privilege are required by the attacker to exploit it, if user interaction is needed, if the scope of, say, the trust boundary of the vulnerability, or if the vulnerability is breaching the trust boundary scope, essentially. And then what kind of impact does the vulnerability have? Is it confidentiality, integrity, or availability? There are also temporal metrics and environmental metrics. We won't go too much into those. They're not used as much, and also the study doesn't really take them into account, so I will leave them. I just briefly want to mention then also that this is perhaps also a topic, I will come back to it a little bit, that from these metrics there is a very transparent but not entirely intuitive algorithm to calculate the number. So that's how it's working. Now, so for the motivation about the study, I was already mentioning it, and one criticism perhaps is that, or has been around, is that the assessments are kind of subjective, that it would depend on who is doing the assessment. And also there is very little general empirical support of the metrics being correct in one way or the other. The framework per se, the CVSS framework, is also evolving. So now it's in its version 3.1. So what does that really mean, or what does that mean when it comes to the trustworthiness of the scoring system? We will come back to that also, but that's a little bit of background. So the study per se that we did, we were looking into five bigger vulnerability databases. So the NVD, as already introduced, IBM's X-Force, the OSVDB, and Carnegie Mellon's CERT-VN, and also Cisco's vulnerability database. So I should also mention here in the study, we used data up until February 2016, and at that time, most of the data was in CVSS version 2. So all of the data and all of the results we get here is based on the version 2 of CVSS. All right, so what did we try to do? Well, essentially, just as much research is doing, say typically empirical research, is that we're trying to fit data into a mathematical model. So essentially the whole idea is to look at available data and then try to build a model that explains as much as possible of that data, so that the model then can be used to predict the future. In this study, we used Bayesian statistics. So very briefly about Bayesian statistics, it's then not perhaps what most are familiar with, which is the frequentist approach, we can call it, where the frequentist approach is essentially trying to observe things and then count the number of observations of different phenomena. The whole underlying idea with Bayesian statistics is that we have we have beliefs about different things. So we start with prior beliefs, and then the more we observe, the more certain we get about the things we're observing. But the whole fundamental idea is that we're kind of just increasing our beliefs. We start off by not knowing very much about the subject, and then the more we observe, the more certain we are. So we're never really disproving anything. If we observe contradicting data, then we start to believe different things in less, essentially. So this is very convenient when we don't really have a ground truth, which is the case in this particular study, because what is the severity of a vulnerability? Well, the ground truth of that is, of course, a little bit vague. Okay, so for the model, I'm jumping now into the, we're moving away from the background to the actual study. So this is a picture illustrating the model that we did. And then I hope you can see my cursor here. So the idea is that we have vulnerabilities. Every vulnerability, we assume that every vulnerability in the databases, they have a true value, represented by this node here. And then this true value, this is influencing how the different databases are actually scoring the vulnerability. It's also the scoring per se. So this is what we can observe. The squares here, this is what we can observe. We cannot observe the round things. The scoring is also determined by, say, the performance of the scorer working for the database, essentially. So they could be more or less skilled or correct or so. So that's the overall model. And what we are interested in essentially is how well are these scorers performing. Before I go into that, I will just come back to, and then, which I already said in a way, what we have here is then the version 2 of the CVSS. So all of these boxes here, they come in multiples in the sense that they are all, we have values for all the base metrics of CVSS version 2, which are these. These are not the exact ones that I presented initially. So, so that's the setup. So there are many dimensions in which the scorers score, so to say. The way we then measure the how well the scorers perform is by looking at confusion matrices, or confusion cubes, we perhaps want to call them in this case. Essentially, this is the way, so it's a neat picture, but it's also, if I explain it to you, quite illustrative in how it works. So if the actual score is, say, network here, then there's a certain probability that the scorer also score it as network for the access vector here, one of the base metrics. In this case, we have a very good scorer. So essentially, it's a perfect scorer. For all vulnerabilities that are actually network, they also do score it as a network. They don't score it as adjacent, the orange field here, or local, the green field here. So all the small dots here in the cube, they are different. They represent like a probability distribution. So normally we would perhaps see a probability distribution looking like a normal distribution in a diagram, but here we have our distributions represented in a different way by the different dots in this case. Now, here's another example. If the actual score is local, then we also want the assigned score to be local, which is here. Now the score is quite good, but there's a certain chance here that the scorer is scoring this as network. So we know that the scorer is, say, not perfect in its scoring. Sometimes the scorer confuses network or local as network. When it comes to the adjacent scoring, then we have quite fluffy, say, clouds representing that we don't know. In general, it seems to be that, well, they are at least scoring quite good. So adjacent sort of ends up in adjacent, but for other reasons, for other times, it might also end up in network or local. So ideally, the scorer should have like thin clouds, or no clouds at all, just thin slices on top here. This one should be filled, this one should be filled, and that one should be filled. So that's how the evaluation goes. Now, coming back to this Bayesian approach, and I want to sort of just highlight this again, because this is perhaps the most difficult thing to take in about this study, that how do we really measure now how well the scores are if we don't have the ground truth? And strictly speaking, we cannot. But it's, again, we're maximizing, we're trying to build as good a model as possible. So with a lot of consistent data, we also then can be quite sure that it is correct. All right, so coming to some results then. So here are all the different base scores: access vectors, access complexity, authentication, confidentiality, integrity, availability. As you see, in general, it looks quite good. There are a few places where MVD is not so good. There is one problem we had is that, and this is the exact one I showed you previously, that when it comes to the access vector, or for this, sorry, for the access vector and the adjacent score, there was very little data. therefore, we don't know so much. We have a lot of uncertainty there because we're lacking data points, essentially. The same goes for multiple authentication. So these are the places where you can see that here are big clouds. These are areas where we have high uncertainty. We can also see that they are not so good at scoring low access complexity. Here, the slice here. We would have liked this cloud here to be up here, but it's not. So that's a place where they are not so good. In general, however, we can see that we have the results being quite high up on this diagonal where we want them to be. So pretty good. And also the NVD here was the overall best performing database in the study. So this is as good as it got. Here's an example of Carnegie Mellon's results. Not at all as good, and in general, it had a lot fewer data points, so there's much more uncertainty here, as you can see. But yeah, in general, not scoring as good. Okay, so that was the detailed analysis, and you know, if you're more interested, you can go into the paper and read all about it and make your well, thoughts about that. If we're trying to go the other way and try to aggregate, what are the results? So here's another way of trying to aggregate things. And then how well did they perform? How accurate was all of the scorings, all of them taken all together? And then say the most aggregated result we got was that NVD was on average 93% correct, and then the worst score we got was for OSVDB on 77% correctness or accuracy. Another type of result that we got that is kind of interesting to have a look at is that all the data in there is distributed according to this. So in general, there's a lot of, say, net access vector of networks, 88% of them. So, so this is what sort of the characteristics of all the reported vulnerabilities, they look like this. We could start thinking about how can we use this. So if we, and this is also how you apply Bayesian reasoning and to you know, say something about a certain instance of vulnerability. So if we just observe a new vulnerability, we know nothing about it, then in general, we would believe then that to 21%, we would think that it's a confidentiality impact scored as complete. That's just our base belief. If we also learn that NVD was scored with that score, well, our belief would increase that this is correct to 85%. And then if further scores are confirming this, we would be, after looking at them all, we would be very, 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 very certain, 99.9999%, but not 100, 99.9. And then if we get contradictory scores, we would start decrease our belief. So if then say X-Force scored it to partial impact, well, then our belief would go down to 98 and so on. So that's also something you can, how you can say, use this as confirming your own beliefs. Okay, so what does CVSS2 say about CVSS3? Well, one thing which was also, say, part of our results is that there is kind of some places there's a lot of uncertainty. And access complexity is one of those places, and it was also updated in version 2 or in version 3. So this is in line with our result that this was a good move. And in general, the CVSS version 3, the base metrics there, they are less, say, subjective to nature. In general, I also think that the people working with vulnerabilities, they are probably becoming, say, more and more skilled over time. So to me, it feels natural that CVSS would be at least as good as CVSS version 2, even though there are no, say, strict academic support for that. So the overall conclusions here is that well, we have empirical data and also general arguments suggesting that we can actually trust CVSS, and in particular NVD would be the best source for looking into vulnerabilities. And by just looking at NVD and just trusting this would be, I guess, it would be quite straightforward. If you have a vulnerability, if your score is really, critical for various reasons, your decisions around it will impact important stuff. Well, it would make sense to actually double check it with other scorers so that you are increasing your beliefs. And to say something about how does this relate to say, threat modeling and SecuriCAD that you will hear more about. So this was all about base scores, and base scores is trying to say something about, say, the inherent property of the vulnerability per se. Of course, as CVSS is also saying, this is not all. So in particular, the environmental score and the context in which the vulnerabilities exist is of key importance. And this is also what the SecuriCAD is working with, and what you will hear more about. So a way to connect the speeches here is perhaps that if we have a lot of vulnerabilities, they are there as individual dots, and what SecuriCAD is trying to do is to connect the dots to see how they relate and what combinations of vulnerabilities are really severe at the end. All right, that was that.
Thank you, Mathias. We did get a couple questions here. And one of them is from Anilud that asked the question, who has decided the reference for the actual score?
The reference for the actual score. So the CVSS framework per se is hosted by and run, and I think also developed by the FIRST organization. So they are also the ones, I think, that are responsible for sort of evolving the framework per se. But of course, you can also say, well, what does it mean? I think the number, it's like an indicator to say something about it. With the base metrics, they are, at least the way that I want to interpret them is that they are trying to characterize vulnerabilities. So does the user need to interact? Does the user need to do anything in order for the vulnerability to be exploited? That's kind of a characterization that is useful knowledge. I don't know if that answered the question, and I guess you don't know either.
Well, I hope it answers your question. We have another question here from Darren that asks if we can we learn something from this relating to 0 days?
Well, strictly speaking, I guess not, since CVSS is all about characterizing known or reported vulnerabilities. I think what I take from it, though, is that if the 0 days exist, it still makes sense to me to think of 0 days in terms of CVSS. So, because also with the study that if they were reported, if someone looked at it, they would be good at giving it a correct score. So therefore, they also do have a correct score, is my way of thinking about it. It's just that it wasn't reported. So, and then of course we could start doing other studies, which we also have done at KTH, and trying to think about, well, given reports on vulnerabilities, can we say something about how much of 0 days does there exist out there just from the reported data? But that's subject for another talk, perhaps.
Great, thank you. And the final question here from Ritwana. How do you think this would evolve in the future?
The CVSS or this, I think, I mean, so in general, it seems to me that the CVS has a strong foothold. So I'm sure that it will survive, and that will be stronger and better over time. This is my what I think and hope. I think it's a great tool because it's a common language. It's something that a lot of people accept and find useful. So I think it's a good source to build from, essentially, to try to make even more out of.
That makes sense, to be something to be able to gather around.
Yes.
Thank you very much, Professor Ekstedt.